This is a lesson where you find molar mass. Every atom has their own mass. No two atoms have exactly the same mass. So what we can do is we have to find out how much they are. So each atom has own mass. Now you can't weigh an individual atom. Remember, a charcoal briquette has 6.02 times 10 to the 23rd atoms in it. So you got to go so small you cannot weigh. We don't have any scales that delicate that can do that. So instead of weighing one individual atom, what we do is we weigh a molar mass of atoms. A molar mass is 1 mole of the atoms, and you look that up on the periodic table. It's the decimal number. Whatever the decimal number is on the periodic table, not the whole numbers, it's the decimal numbers. You'll have a decimal point in it. My periodic table will be all to the nearest tenth. The label is grams per mole. So if you look on your periodic table, you'll notice that helium has a decimal number of 4.0, which is grams per mole. So 1 helium atom, or 1 mole of helium atoms, has a mass of 4 grams. The molar mass of sulfur is 32.1 grams per mole. Okay? If you have a molecule or a compound, you'd have a molecular mass. If you have a molecular mass, you just add up the masses of the individual atoms. So if you have water, hydrogen is 1.0, but there are 2 of them, plus 1 oxygen will give you 18 grams per mole. Now when you add, remember my rule is there is no rules. You just add up the numbers. There's no rounding and adding, especially since they all end in a tenth, in which case you don't have to worry about it. Sodium chloride, 23.0 plus 35.5 adds up to be 58.5 grams per mole. Now if you have something like calcium chloride, calcium is 40.1 plus 35.5 times 2. So that's 70, so that's 71. That's 111.1 grams per mole. If you have calcium hydroxide, now there's 2 ways of doing this. You can call this calcium, which is 40.1, plus 16 for the oxygen, plus 1 for the hydrogen, then times by 2. 17 times 2 is 34, add it to 40. Or you can distribute 40.1 plus 16.0 times 2 plus 1.0 times 2. You can go ahead and do the math on your own on that. If you have something like copper 2 phosphate, distributing would probably be the easier way to do with a polyatomic ion. Here you have copper, which I think is 63.5, but I'm not sure, times 3 plus phosphorus, which is 31.0 times 2, plus oxygen, which is 16.0 times 4 times 2 is 8. And then combine those and put them together. Now you could have done phosphorus 31.0 plus 16 times 4, then that times 2. It works the same way. That ends this lesson on finding molecular mass.